Assalamualaikum and a very good morning to everyone. We are from Group E Boys Trio. We are consist of three. Our first group member is Ahmad Daniel Fakih bin Ahmad Rizwan. The second one will be me, Wa Muhammad Diodin bin Wa Muhammad Bilal, and the last one is Rashid bin Rusdi. We will present our topic for today, that is application of differentiation. We have selected the related rate subtopic in this presentation in order to guide you and show you how to settle down the problem regarding the related rate problem. We move to other slide. What is differentiation and when to use it? Differential calculus is a subfield of calculus that studies the rate at which quantities change. It is one of the two traditional divisions of calculus, the other being integral calculus, the study of the area beneath a curve, which will not be discussed in this presentation because we have selected the related rate as our main priority in this presentation. Differentiation allows us to find rate of change. For example, it allows us to find the rate of change of velocity with respect to time, which is acceleration. It also allows us to find the rate of change of x with respect to y, which on a graph of y against x is the gradient of the curve. There are many number of simple rules which can be used to allow us to differentiate many functions easily. So based on the two statements here, we know that differentiation allows us to determine the rate of change of certain function that we will have a discussion later on by our other group member, that is Rashid and Ahmad Daniel Fakih. It also allows us to find the slope or gradient or tangent of a curve, which will not be discussed in this presentation because it is in other subtopic. And bear in mind that differentiation also can be used in order to find the minimum value or maximum value of a certain function at a certain point. That will not be will be discussed in this presentation. So we know that differentiation got a lot of use in order to solve the calculus problem. So we will have our example with a solution that will be discussed by our other group member, that is Ahmad Daniel Fakih and Rashid.
Now I will present to you the question that my team have chosen. The width of a rectangle increases at a rate of 2 cm per second. The length is 5 times its width. Find the rate at which the area is increasing when its width is 5 cm. So given that dx over dt is equal to 2 cm per second, find dA over dt when x is equal to 5. Next, I will show you how to solve this problem. There are two methods that we could use in solving this question. The first method is chain rule. The second method is implicit. So now I will show you how to use chain rule to solve the question. So we have to use the information that have been given to us. So the question have given to us dA over dt and dx over dt. Now we have to find the relationship between these two. So dx over dt can multiply with dA over dx to get dA over dt. Now we have to find dA over dx. To find dA over dx, we first have to find A, or the area of the rectangle. The area of the rectangle is equals to the width of the rectangle times the length of the rectangle. The question has given to us the length is 5 times its width. So the width of the rectangle is x and the length of the rectangle is 5x. So x times 5x is equals to 5x squared. Then we have to differentiate a with respect to x to get dA over dx. So we will get 10x. Then finally we have to find dA over dt. So we have to substitute dx over dt with 2 and dA over dx with 10x. Then we have to substitute x with 5 because the question said find dA over dt when x equals to 5. So now we have to solve the problem. 2 times 10 times 5. So the answer is 100 cm per second.
After using chain rule, we try using implicit differentiation. So we already know that the area of rectangle is 5x the power of 2. So we use formula dA per dt equal to 10x multiplied with dx per dt as x equal to 5. So we have to differentiate both sides with respect to t time. So we change the x into 5, so we got 10 multiplied with 5 multiplied with 2, so we got the answer is 100 cm square per second. That's all for implicit solution. So the conclusion of our topic is differentiation and integration can help us solve many types of real world problems. We use the derivative to determine the maximum and minimum values of particular function. Example, cost, strength, amount of material used in a building, profit, loss, and others. Derivatives are also made in many engineering and science problems, especially when modeling the behavior of moving objects. This is our references. We using our textbook Calculus 1, Science and Engineering, and also research on website. That's all from us. Thank you.